Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run decision tree in SPSS. Decision trees are a type of a supervised learning algorithm used for classification and regression tasks. They represent decision-making processes in a tree-like model. Let's see the difference between logistic regression and decision tree. We start with the concept. Linear model for binary classification. Non-linear model that splits data into subsets. Assumptions. Linearity between features and log odds. No specific assumptions about the data distribution. Second assumption in case of logistic regression is independence of observations. Output. Probability of class membership. In this case, class level or continuous value for regression. Interpretability. Coefficients for features are easy to interpret. Tree structure provides clear decision rules. Complexity. Relatively simple, computationally efficient. Can become complex with deep trees. Handling non-linearity. Limited unless using polynomial or interaction terms. Handles complex non-linear relationships. Overfitting. Less prone to overfitting. Regularization used. Prone to overfitting. Pruning techniques can help. Flexibility. Suitable for linear boundaries. Flexible, can handle non-linear boundaries. Handling missing data. Requires imputation of missing values. Can handle missing values with certain methods. Performance with large datasets. Efficient with large datasets. Can become computationally expensive with large datasets. Applications of decision tree. We start with medical diagnosis. Diagnosis, diagnosing the disease such as cancer, diabetes, or heart disease based on patient data. Second application is predicting whether a loan applicant will default on loan based on their credit history and financial behavior. Marketing. Identifying potential customers for specific product based on their demographics and past purchase behavior. Fraud detection. Detecting unusual credit card transactions that may indicate fraudulent activity. Customer support. To classify and prioritize customer support tickets and route them to the appropriate department or personnel. Retail. To optimize inventory management, product recommendations, and store layout. Insurance. To assess risk and determine insurance premiums based on various factors. Manufacturing. Predicting equipment failures or defects based on historical data and operational conditions. Healthcare management. Deciding on the most appropriate treatment plan for a patient based on their medical history and current condition. Travel and transportation. Determining the best routes for delivery trucks based on traffic patterns and delivery schedules. Now let's try to understand the concept of decision tree with this small case. We want to predict if John will play tennis, yes or no, based on the environmental conditions. Three environmental conditions are there: outlook, humidity, wind. Once the decision tree is created, we want to predict for the new data that John will play tennis, yes or no, in this environmental setup. So we'll start with the second variable, which is outlook. Outlook. Three scenarios are there: sunny, overcast, rain. So if outlook is overcast, it's clear-cut indication that the John will play tennis. So it's known as a pure subset. Four yes are there. So out of 9 yes, 4 yes are only present in overcast. Now let's proceed further. If it is rain, if it's raining, so 3 yes are there and 2 no are there. So we will have to split it further. In case of sunny, 2 yes are there and 3 no are there. So this will also be splitted further. No, it's not required to split further in this case because it's a pure subset. Now sunny. Then we talk about what is a humidity level. So this is the second environmental setup. So 2 yes and 3 no. So further split is required. Sorry, humidity levels. So here it is high, it is normal. So if it is sunny, humidity is normal, John plays the tennis. If humidity is high, John does not play tennis. So this is now, both of them are pure subset. No further splits are necessary. In this case, rain, and then we check for wind. If the wind is weak, John plays the tennis. If wind is strong, John does not play the tennis. So we don't require any further splitting here also. So now we will give the new data. The outlook is rain, humidity is high, and wind is weak. So John will play the tennis, yes or no? The answer is yes, the John will play tennis. Now we will go in SPSS data set. So we are having a credit rating of the customer. So you can see 0 is coded as bad, 1 is coded as good, and 9 is no credit history. Now we would require a decision tree based on age of the customer. So which age group customers are having good credit rating? Then the next is income level. How many credit cards the customer is having, education of the customer, and car loans. So now we will go in analyze, classify, and decision tree. Click OK. So I'll transfer credit rating to the dependent variable, activate the categories, and we want the decision tree based on good credit rating. So in categories, activate good. Now transfer age, income level, number of credit card, education, and car loans in independent variable. Click on output. So in this orientation, top down, note contains table. Keep other things as it is. Now click on statistics. So make sure summary is on, risk is on, classification table is on. Now go in plots. So here also don't make any changes. In rules, generate classification rules. So you want the classification rule in SPSS syntax, SQL syntax. So I will activate simple text, export rules to file, browse, and give the name here. We'll specify rules of the decision tree and press save. Done. Press continue. Now you go in validation. So in this we are having two options, cross validation and simple and split sample validation. Let's understand cross validation first. This is four-fold cross validation. So this is the data which we are having. So if it is four-fold, the data will be divided into 4 parts. Okay, let's understand. In this part, this is a testing data and this is a training data. In second iteration, this becomes the testing data and the remaining are the training data. In the third iteration, this becomes the testing data and the others become the training. So this is known as a four-fold cross validation. So we will go in SPSS. So we can specify number of sample folds 10, or you can also go for the method simple sample validation. So 50% training and 50% testing. If I change the number here 80, so this will become 20. So let's activate the cross validation. 10, continue. Criteria. So here the parent node, make it 10. The number of cases in the parent node 10. So we are specifying the growth limit and the child node 5. Click continue, save, terminal node number, predicted value, predicted probabilities, continue. Options. keep the things as it is and make sure that here you activate chat. So it is chi-square automatic interaction detection. Now click OK. So we got the decision tree. Now what we will do, double click on it, maximize, and here activate the percentage, 150 percentage, so that you can see properly. If I keep 100%, then also it is good. So credit rating, good, bad. So in this, out of 2464 cases, 1444 are having good credit rating and 1020 are having bad credit rating. So we start with node 0. Now you will get the p-value and chi-square. It's necessary that the p-value here should be less than 0.05. The p-value helps to determine whether the split at the particular node in decision tree significantly improves the model's performance compared to a simpler model. That is, should we split further or should we not split? That is, a simple model is no splitting. Okay. A lower p-value, the p-value less than 0.05 suggests that the split is statistically significant and improves model's performance. So we will proceed further. So the first node is based on the income level. So the income level, if it is low, medium, and here greater than medium. Now in this node, node 1, bad credit rating, 454 customers are having bad credit rating. So the cases are 82.1. In low medium, 476, and in greater than medium, 90 cases are there. So it means that if the income levels are less, the credit rating can deteriorate. Okay, now this will be further classified. Let's check the p-value. It is less than 0.05, so we should proceed further. What is the next question which is coming up? Number of credit cards. Let me expand this. Number of credit cards. 5 or more, less than 5. So bad credit rating, 421 cases are having bad credit rating if the credit cards are more than 5. Less than 5, 33 cases are there. So how many percentage? 38.4. Now let's proceed further. Let's check the p-value. Here also the p-value is less than 0.05. So we should proceed further. Age, less than 35. Here, more than 35. So here we are having 325 cases which are having bad credit rating. It means that if the government, if the organization wants to take any policy decision, so if the income levels are low, credit ratings are more than 5, and if the age is less than 35, so the credit rating is bad. Now let's talk about this part. Age greater than 35. So 96 such cases are there, which the percentage is 78%. Now let's talk about this node. Less than 5, age less than 25. This credit cards less than 5 and the age less than 25. So 15 such cases are there. Here 16 cases are there, and in this 2 such cases are there. So here reasonably we can say that all those who are having less than 5 credit cards, their credit rating, overall credit rating is good. So you can see the percentage here, 92, 60. Okay. Now let's come on this side. Number of credit cards, 5 or more. In this, again, the bifurcation according to the age. Okay, and here less than 5. Similarly, again we will go on the income level, greater than, medium, 5 or more credit cards. So here it is good credit rating, and here also less than 5, good credit rating. And age less than 28, number of cases 70, percentage is 66.7. Here number of cases 133, and the percentage is 79.2. So this is how we interpret the decision trees. Now it also gives me the classification accuracy of the model. So where you will get it, see, we had activated this tree editor, close it, and go at the bottom. This is a classification tree. 729 are such customers, that is, the original data said the original data, it was having a bad credit rating, and the prediction done by the decision tree is also bad. This means that 729 are such cases which are being correctly classified by the model. Now let's talk about this good. The original data good, and the prediction done by the decision tree is also good. So 1, 2, 7, 8 are such cases in which the prediction aligns with the original data. Here also the prediction aligns with the original data. So 729 plus 1278 are the correct classification. Misclassification occurred in 166. The original data is good credit rating. The prediction done by the model is a bad credit rating. And here in the first row, the original data bad credit rating, and the prediction done by the model is good credit rating. So 166 plus 291 are misclassification in the data. What is the classification accuracy of the decision tree model? 729 plus 1278 divided by total number of customers. So how much is it? Let's see, it is divided by 2464 will give me this figure, this one, 81.5%. Okay, now we will go in the data to identify the misclassification, where the misclassification has occurred. See, this is the credit rating, the original data, and this is the prediction done by the model. Okay, this is a prediction done by the model. So what we will do, I will drag it and bring it here. Now let's go in the variable view, predicted value 1. So if you recall, we had specified the target good and 0 bad. Click add, click OK. Go in the data view again. Now see, this is misclassification which has happened. Okay, the original credit rating of the customer is bad, and the predicted value according to the model is good. So this is misclassification. This is correct classification. This is correct classification. Correct. This is misclassified. Let me check here also. Yeah, if there is a good figure here. Now in this case, the customer is having good credit rating. No, in this case, but the model predicted bad. So this is also misclassification. So in total, the misclassification happened in 166 plus 291 cases. Now you will also get the rules of the decision tree. If you recall, we had saved it in the notepad format. So here are the rules in the notepad format. If income level not missing and income level greater than or equal to low, and number of credit cards less than 5, and age. So what is the probability? Okay, prediction 0. So you will get the decision rules for the nodes in the notepad. So this was all about how to run decision tree in SPSS. For more videos on advanced data analysis using SPSS, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.